Alright, good morning everyone. Today we'll be starting section 1.6, absolute value equations and inequalities. We're just going to tackle equations today, so we're going to do this in 2 days, so this will be day 1. A review of solving equations. If you can imagine doing this two-step in your head maybe, you would subtract the 8 to get negative 4 minus 8, and then it would be 3x equals negative 12, and divide both sides by 3 to get negative 4. Negative 12 divided by 3 is negative 4. Okay, looking at this vocabulary builder, we have absolute value of a number. X is its distance from 0. Don't forget that. Everyone forgets what does it mean to do absolute value. They just know, oh, the answer is always positive. Well, that's not really what the definition is. It's how far away from 0 are you on the number line. So if x is positive, then the absolute value of x equals x. So absolute value of 5 equals 5. Then if x is negative, this is a typo actually. This is a typo here. The absolute value of negative x equals x. That was a typo. So the absolute value of negative 5 then gives us 5. Alright. So looking at using the vocabulary, graph each absolute value on the number line. So the absolute value of 3 would well be 3, so that would be right here. I'm just going to put the absolute value 3 above it. The next one is absolute value negative 2. Well, that is also going to be a positive 2 on the number line. This one's a little tricky. The negative is not inside the absolute value. This is kind of like, think of the absolute value as a parenthesis. You take care of the parentheses, take care of the absolute value first, and then if there's stuff outside, then you apply it. So ignore the negative. Absolute value of 1 is 1, so it would be right here, but then the negative makes it negative. So be careful with that. This one, again, it's kind of like order of operations here, kind of, where you can ignore the 2. The absolute value of negative 2 would be positive 2. So it would be right here. But then you times it by the 2 out front, which then becomes a 4. So this right here is where the 2 absolute value of negative 2 goes. Alright. Looking at this one, complete each graph. So the absolute value of x equals 4. Alright, so this is where it gets a little tricky. If we have a variable inside of the absolute value, because the absolute value of what number gives us 4? Well, the absolute value of 4 works, right? The absolute value of 4 equals 4. Okay? But the thing about absolute values is that's not the only answer. There is another number that if you take the absolute value of it, gives us 4. And you can kind of think about it to yourself for a second. You can also get a little hint here from the number line. The absolute value of negative 4 also equals 4, doesn't it? So if there's a variable in the absolute value, more likely or not, you're going to have 2 answers. There's our 2 answers. Okay, if you take the absolute value of either of these numbers, it equals 4. Same idea with this one. The absolute value of what number gives you 5? Well, absolute value of 5 works, and the absolute value of negative 5 works. They both give us 5. Okay. All right, move on. All right, here we are solving an absolute value equation. So, as we just kind of saw with the previous problem, the idea here is we're going to have 2 answers, actually. If this was a regular equation, we'd only have 1. But when they're in absolute values, variables absolute value, then we're going to have 2 answers. So how do we solve it? Well, we have our normal answer. This is what happens. Let's just rewrite it and just rewrite it without the absolute value bars. Just figure out what makes 3x plus 2 equal to 4. Okay, like normal. Just like how here, if we lost the absolute value bars, it was just kind of like x equals 4. That's one of our answers, right? It's just there's nothing really to do, just x equals 4. For the other one, we also want to figure out, just like how we had, we want to figure out, well, if x was negative 4, that also equaled our answer we wanted. We have to figure out what makes the inside part negative 4. The last one, there was no 3 or 2, so we just wrote down x equaled negative 4, right? But now we have got some work to do. We got to figure out what makes 3x plus 2 equal to negative 4. Because if we figure out what makes this equal to negative 4, then we know the absolute value of negative 4 equals 4, just like the absolute value of 4 equals 4. So we essentially write down two equations, and we just lose the absolute value bars in one, and we make whatever numbers on the other side negative for the our negative route answer. All right, let's go. So here we would subtract the 2 to both sides. So we would get, I'm just going to be solving it. I'm not really going to be following along with this here. 3x equals 2. And then we would divide both sides by 3 to get x equals 2/3. Is it our first answer? And let's do the same thing. We're still going to subtract 2 to both sides to get 3x equals negative 6. And then divide both sides by 3 to get x equals, what does this become? That's negative 2. There we have it. We have our two answers. I'm just going to, you can graph on the number line here. So we have negative 2, and we have 2/3, which is between 1 and 2. Or sorry, between 0 and 1. There we go. Okay, that is it. Most likely not. Might not make you just do this for just putting the dots on the number line, but it's always good to know how. Okay, solving a multi-step absolute value equation. So the thing about this is, notice how there was nothing outside of the absolute value bars here. If you have things outside of the absolute value bars, so here we have absolute value of x plus 9, but we have this times 2 in front, this plus 3 sort of after, and all that's on the left-hand side of the equal sign, okay? So what we want to do is we want to get rid of anything that's on the left-hand side of the equal sign that's not really inside of the absolute value bars before we can sort of break it down into our two equations to start solving, okay? So they're kind of giving us some steps here. So if we wanted to subtract 3 from each side, because we have a plus 3 here, we want to get rid of it, we would minus the 3. Okay, 7 minus 3 is 4. And then we want to divide each side by 2 to get rid of this 2 in front. Do not take this 2 and do a distributive property inside thinking, oh, it's kind of like parentheses. It's kind of like parentheses in which you kind of have to take care of what's going on inside before applying outside numbers to it, if that makes sense. You cannot do a distributive property with an absolute value. If you've done it in the past, there is sometimes you can do distributive, but because it's not all the time and there's only sometimes, I'm just not going to worry about teaching when is it okay to distribute into an absolute value, and just going to say just never do it, because you can always solve without doing it, okay? So don't distribute the 2. Divide both sides by 2. Divide by 2. These 2's cancel. 4 divided by 2 is 2. So here, this is our new equation, our new absolute value equation. that we can now break down, and it looks similar to this now, right? This had no numbers outside the absolute value, and it was ready to be broken down into our two sort of equations here. We can now take this and break it down to our regular equation. X plus 9 equals 2. Just rewrite it, lose the absolute value, and we can go to our sort of negative route that figures out what makes x plus 9 equal to negative 2. Make the number on the other side negative. And now solve them like normal. You would minus the 9 to get x equals 2 minus 9 is negative 7. Okay, that's our first answer. Minus the 9 here. I know that sometimes it wants us to rewrite it first and then go, and I just kind of start doing my work here. Negative 2 minus 9, what is that? That's negative 11. Okay, so we have negative 7, which is in between negative 8 and negative 6. And then we have negative 11, which is between negative 10 and 12. There are two answers. All right. I think we got one more. Okay. So, with this, there sometimes comes extraneous solutions. Extraneous. It pretty much means it's a bad answer. There's sometimes when you're solving equations, you get an answer that doesn't actually work, and you have to sort of check to make sure it does. Okay, you might have run in this when we solved solving square root equations in Algebra 1, maybe. So, if you notice that there's an x on the left-hand side, and that there is an x on the right-hand side, this is if this ever happens, and you want to solve it, you must check at the end for extraneous solutions. Okay. What they're saying is, let's say we did solve this like normal. Okay, and let's say that you ended up with x equals negative 1, x equals negative 8. Those are two answers that you got. We're not actually going to solve it, but it's telling us that's what you would get if you solved it. The problem is one of these might be a bad answer. Okay, it might not work. So once you solve it like we just did normally, now what happens is, let's take this, I don't know, let's take this negative 1 and plug it in for our x and see if it actually bounces out the equation. So if we plug it in, we get 5 times negative 1 minus 2 equals 7 times negative 1. I'm going to use a little parenthesis here. So what is this? This is negative 5 minus 2 is negative 7. This is negative 7 plus 14, which is positive 7. So is the absolute value of negative 7 equals 7? Yes. So this one works out. Nothing wrong here. This negative 8 might not work, though. We have to check. So we're going to plug in the negative 8. I'll use parentheses just to be a little careful here. This is, what is this? This is negative 40. Minus 2 is negative 42. This is negative plus 14. This is also equals to negative 42. So what happens here is this equals negative 42, but the absolute value of it should equal a positive 42, right? So because the absolute value is always positive, this one doesn't work. Okay, and this is our only answer here. Only the answer of x equals negative 1 is the only good answer. Is solution let's see here. You can use your own words here, but x equals -8 gave absolute value -42 equaling -42, which is incorrect. And we're going to stop here. We're not going to go to absolute value inequalities just yet. So we're just going to take a look at this. Head over to the Math Excel and check out what's on there. See you guys next time.